Well, thank you all for inviting me to talk today. I'll turn on my camera real quick to just say hi. For some reason today my camera started to flashing and strobing, so I will turn it off here momentarily. And then let me start sharing our presentation for today. Iman, can you see it?
Yes, I see it full screen.
Perfect. Well, again, thank you for the opportunity to talk about Georgetown, a project that I've been involved with since 2014. So going on 6.5, 7 years now. And today we'd like to talk about how our team used virtual reality and augmented reality, as well as cover some of the innovative stormwater features that are being implemented and will be constructed pretty soon at the county's Georgetown Wet Weather Treatment Station. I did notice from the attendee list that we have a lot of staff that worked on the project. So feel free as I talk through some of the components related to Georgetown. If you want to add a point or two, feel free to chime in. And with that, before we get started, I did want to make sure that we acknowledge some of our teaming partners. A lot of the material that we'll be talking through, especially slides, were developed by them. So wanted to give a shout out to others at Jacobs that pulled slides together, as well as Berger Partnership, Miller Hull Partnership, and Signal Architecture and Research. So I've broken down our talk into 3 parts. Part 1 will cover kind of the background of Georgetown Wet Weather Treatment Station and why the project is necessary, why the county's building it, why we designed it, and why it's being constructed currently. Part 2 will focus on how we use virtual reality during the design phase, and then how augmented reality is being used during construction. And part 3 will focus on some of the innovative stormwater design approaches that were used. And we'll do our best as we can to showcase the VR and AR component. Obviously, those technologies work well live in a room together, but we'll have some interactive components. So part 1, background, Georgetown Wet Weather Treatment Station. So to understand the project, we need to understand a little bit of how the history and conveyance systems and sewer systems were constructed in Seattle. So around early in the 1900s, the first pipes were installed in the Seattle area, particularly in our Georgetown area here, the map off to the left. All of the sewers were primarily designed to flow by gravity to receiving water bodies. Namely here, the Duwamish River. There's also a screenshot off to the side here of a hydraulic model. And so generally as sewers were built, they convey by gravity, so everything slopes downhill to those receiving water bodies. Even though ground topology may vary. And at the turn of the century, they didn't have all the tools and techniques that we have today. So all that work was done by hand. And mining, and individuals would go in and mine these pipes. So a lot of the original pipe sizes were set by what a person could fit to do the work. So glad we have OSHA now to keep us safe as we construct materials and build conveyance systems. Around the 1960s, we started implementing traditional wastewater treatment. And so interceptor sewers were constructed in the area and across Seattle and the county, conveying flows to our regional treatment plants. The orange line on the diagram here, this is the Elliott Bay Interceptor that was built, and it intercepted the combined sewers and conveyed flow to West Point. And so the control structures were developed at each of these intersection points where the outfalls could become relief points for when the system was at capacity, And currently, each of the points at Brandon and Michigan, they overflow around 20 times per year. The diagrams on the right-hand side kind of showcase how the system works under different conditions. So a combined sewer system under dry weather, you generally have household, residential, commercial sewer flows flow down into the system and then get conveyed to the treatment plant for treating. And then when it rains, as it does a lot in our Seattle area, runoff from roofs, as well as storm drains and collections from roads will enter the system. And early on in the event, it will, of course, make its way to the treatment plant. But as the conveyance system capacity is exceeded, it'll then overflow out to the receiving water bodies, Duwamish River, here for Georgetown. And as environmental permitting and requirements, EPA and others have done research and studies, have imposed regulations for CSO outfalls. And the current regulation is to have about 1 overflow per year. So with each of the Brandon and Michigan outfalls having around 20, we're not in compliance with regulations, and that is why the Georgetown project is necessary. So its goal is to bring these outfalls into compliance. So moving on into the Georgetown and where it's sited. So it's sited kind of right at the heart or entry level to the Georgetown area. The site is 2.3 acres in size, where the treatment facility is being located and currently constructed. The third component is building the conveyance system to bring water into the treatment station, as well as to let the treated effluent back out to our outfall. So there's around 3,000 feet of conveyance piping, and then a new outfall has been constructed to the Duwamish River. Some particular components to Georgetown or parameters. The treatment station will have the ability to treat 70 million gallons per day. Our screenings facility is sized to handle 150 million gallons per day. The reason why that is a higher number than the 70 is that we have equalization after screenings. So we're removing screen material prior to going into equalization, and then the equalization basin will buffer the influence such that we can treat the 70 MGD. The rest of the treatment process, ballasted sedimentation, UV, and then our outfall, they're all designed for that 70 MGD flow rate. Our anticipation from modeling is that our peak event volume will be around 85 million gallons. And on average, the facility will treat 67 million gallons a year. And again, have an average number of events of around 20 plus or minus. And then events last anywhere from a few hours to a few days in length. Operationally, so how Georgetown fits in with the existing infrastructure and the EBI, we are doing some slight modifications to route the EBI through the new Georgetown regulator. And so it'll intercept flow, and normal dry weather flow will just go through the new regulator and continue on through the EBI to the West Point treatment plant. Under wet weather flow, we'll start diverting flow to the EQ basin, and so it will fill up. And if it's a light rain or a mild storm event, we'll have the ability to just store it within the EQ, which provides around 1.1 million gallons of storage. And so after those smaller events, we have some drain pumps in the EQ basin, which will pump flow back to the regulator, where it will be stored via, or pump back to the regulator, where it will be discharged to the West Point treatment plant. And under heavy flow, the EQ basin will fill up to a point where it engages the treatment system where there's 2 treatment trains. Each train will do 35 million gallons. And then the treated effluent will follow the new conveyance line out to the Georgetown River. So going through the particular processes for the treatment station itself, we'll highlight those real quick and then we'll move into the VR. So line 1 here is the Michigan trunk influent along the EBI, and so combined sewage and stormwater will be in that pipe. It'll go into the regulator station here, and depending on what flows are going on in the system, different gates and things will modulate to allow flow into the treatment station. If we're having an event that requires flow to go to the treatment station, it will send it here. This is where our screenings facility is. And the screenings facility sits on top of that equalization basin. As far as my impact or work in the design, I was in charge of designing and leading the team that was working on this facility here. So I have the most knowledge here, so if you have questions on the other portions, hopefully some of our team members that are on the phone can answer those. The screening facility, after flow goes through the screens, it'll drop down through a drop structure, which was heavily designed and actually had some computational fluid dynamics modeling done to make sure that we designed a system that slowed the velocity of the water down so we wouldn't get it too mixed up. After the EQ basin fills, the influent pumps are here, which then pump flow over to our rapid mix station, our process where we add chemicals to speed up the sedimentation process. From there, we move to our hydrocyclones, which are located in this building here, where sand is mixed in, which helps the solids material attach and drop out. From that, we go to our ballasted sedimentation, where fine particles will drop out. So all of the solids that occur in these first 3 steps that accumulate, those are collected and conveyed into a solids holding tank, which is located back here. And the solids are kind of stored until there's capacity in the system. So those get pumped back into the sewer for further treatment and digestion at West Point. The water that is gone through goes through treatment. It goes through a UV disinfection where all the bacteria is killed. And then from there, it gets routed as treated effluent back to the Duwamish River. A quick project schedule timeline. Currently, we're right in here. So construction's ongoing. This made a lot of process. I think they recently just set the first of the 6 pumps at the influent pump station, and then design is scheduled, or construction scheduled to be completed in 2022. So that's a quick overview of the background on Georgetown, what we're a treatment station, and why the product's required. I'd like to take a moment to pause for any questions or any comments from our other design team staff that are on the phone. Anyone with questions? See, checking our chat. No one's in chat. All right.
Hey, Brian.
Yeah.
This is Tina. I'll go ahead and add a little bit on that schedule. So on the conveyance side, we actually should be finished with that probably by about June. We've hit a major milestone recently there with a pipe ram. We were able to connect all the pipes. So we now have connected effluent pipe all the way through to a completed outfall. And we're looking at startup testing, probably starting in July of this year. and going through February of next year. So hopefully we're hitting substantial completion, maybe around 6 months ahead of the consent decree milestone at the end of 2022.
Awesome. Cool. Thanks, Tina.
Mm-hmm.
All right, so let's move on into part 2, which is probably why everybody joined today's call. So how
Brian,
virtual reality...
Sorry, Brian, there was one question in the chat, if you can see that.
Yes, David. So the design is to limit one untreated event per year. So the goal of Georgetown is to treat everything, but there are occasional storm events where the inflow is greater than what we can buffer, and so those, Tina, help me here, will still overflow. Sure.
Yes, so to meet ecology guidelines, they require that you control everything up to one overflow event per year on a 20-year rolling average. So based on the county's modeling data, it indicates that at Michigan and Brandon, each one of those outfalls will still overflow. Those historical outfall points will still overflow one time per year, even with this treatment station. So it's the very largest event we would not be treating. And that helps save capital improvement dollars. So we're not building a huge facility that would get fully used only once a year.
Yeah, now we got some dialogue. Yeah, David, so we did include some climate change in our modeling and held back some reserve events for unplanned changes. So yeah, those were accounted for. And Lisa, yeah, the city of Seattle as well as the county, we've been working on controlling CSOs and building projects for 10 years. And there's a lot of extensive monitoring going on. Cool. All right, so let's move on. Sorry, the video is distracting me. Back to part 2. So part 2. So how virtual reality was implemented during design. So VR, like right about in the middle of the process for Georgetown, you know, VR tools started becoming available, and methodologies for individuals like myself that aren't computer programmers by nature were able to start implementing and taking some of the work and seeing how this evolving industry could be put to practice in our capital projects. And so all of our design work you know, is done in CAD, and for large projects like Georgetown, we do all the design in 3D. And then make slices of those 3D models to produce our 2D plan sets and specs for our contract documents. And so work being done in AutoCAD, SketchUp, Bentley, MicroStation, all those things can be exported for plan review. Many times, you know, prior to VR and still used today is looking at a 3D PDF, something along those natures, where you can look at a model and spin it around and, you know, try to turn on different sections at different components of the design to showcase the intent of the design team and work collaboratively with our clients. Many times it's pretty cumbersome. The level of control, although Bluebeam I think has added some great additional functionality to what was available at the time that we were in this phase, it was really cumbersome. You couldn't always showcase exactly what you wanted. It was hard to get dimensions and measures, measure things and whatnot. But being able to do it in VR has really been a benefit. And so if you can take your 3D model, and in about 30 minutes you can get it into a VR space where you can have a headset on and do a virtual walkthrough of the space. programs that were used initially was 3D gaming engines. So things like Unity or Epic Games Unreal Engine were used to develop models and walkthroughs. And a model at this level, it'll come in just like it looks like in the design on your computer screen if you're doing CAD work. And so the colors of things will show up just the same color as your level or layer that you're using in CAD. It's not going to be pretty. It's going to be bright and colorful. And this type of model is really good for design team to do interaction, do quick coordination reviews, looking for interferences, checking pipe penetrations, looking for door placement and access, egress components. It all stands out really well and really easily as you're doing a walk. So you can do a quick plan review, being immersed in the space. You can see where everything is and what's lining up and what's not lining up. If you want to go one step further, you can take that initial model and then run it through some additional software that's made specific to do high quality VR and renderings and visualizations. This does take some time, so it's a bit of an investment for a facility the size of, or just a portion of Georgetown. So the IPS screening and equalization basin, it took about 16 to 32 hours to develop a model where we applied materials to the wall facades and the pumps and whatnot. And that model was really great for client interaction and review. Other projects where we've implemented this, we've been able to, make design changes and as well as provide facility walkthroughs, in the middle of design. Like, we haven't built anything yet, but our clients can do a virtual walkthrough of the facility we're intending to build for them or design for them, which has provided a lot of feedback early on in the design process. So we can make changes and then be able to bid a plan set that has all of the components that the client needs. And then once you've gone through the process of building this model, you can use it to make 3D renderings and other visualization tools for static images that can be used in presentations like this one. Or for public engagement boards and public meetings and town halls. So the next slide here is an opportunity to have some interaction. There's a QR code in the upper right-hand corner. If you have a smartphone at hand and you use your camera function, it should be able to scan this QR code and it'll pop up with a link. If you tap that link, you'll be able to see a 3D panoramic photo or augmented reality of the pump station side of Georgetown. We'll pause here for a minute. Unfortunately, I don't think we have time to do any troubleshooting if you can't get your camera to work. But I have a screen of the model that I will show as well. So you shouldn't miss out too much. So let me change over to that model. Can someone unmute to let me know that they now see the model instead of the PowerPoint?
I see it, Brian.
Yep.
Cool. Thank you.
Brian, is that
so
QR code? Do you have it? Do you have the actual link? Can you post that if it's not working for some people?
I don't have it close at hand, but we should be able. You'll be able to see it on my screen. The same thing. So it's the model. The model will. Oh, thanks, Bobby. So the model will load. You'll be looking right at our kind of depressed section where our pumps are, and if it was a complete model, you'd also be looking straight across at the treatment side of the Georgetown facility. Unfortunately, at the time, and I don't even know today, the models and files for this product were so large, combining everything together caused computers to crash and smoke. So we did it in pieces. So looking down here, you can see these are the 6 pumps that are pumping flow to the treatment area. If you look, use your phone and you go counterclockwise to the left, you'll see one of our odor control facilities. That odor control facility is collecting air from the EQ basin, as well as the screenings room. If you continue to turn counterclockwise, here's the entrance to the screening room. So if we move, I have the ability to be able to move a little bit. So if we move off to the right, here is our sampling room, where we're collecting samples of the influent sewer to compare with our effluent sampling to make sure that we're meeting our requirement to treat the incoming combined sewer. Off to the left here is our electrical room. And then right in here, this is our screenings room. So here's where the screens are, and they'll collect flow or collect screenings. They'll wash and compact it into dumpsters. Move back to where your view is. If you continue counterclockwise, here's another one of our odor control facilities. And that kind of completes the tour.
So Brian, our view does not allow us to walk.
Yeah, yep. And unfortunately, yeah. So yours is just a straight shot. I will plug though that the technology is advancing to the point that the QR codes in a future update of the software that was used to create these will upload a full AR model of the facility. And so if you are viewing this in a location where you can walk around, you can actually do the same thing that I was able to do on my computer and physically walk using your phone's GPS to navigate through the model. So that's pretty exciting use for the technology. So you go back to our presentation. Here's a few renderings that our architect and landscape architect developed. So after you have built that high-vis model, you can make renderings that showcase how the project will fit with current or the existing surroundings. So here's a look at Michigan and 4th Ave. And the products is kind of that gateway view into the city or into the Georgetown area. Here's kind of a rendering of the placemaking spaces for public. So this is the area where public will have interactions. Part of the facility has a conference room. We also have one of our main art features here, the Monument of Rain. And so that will be a public art kind of installation that will showcase rain or simulate rain. And then I believe it also will act as a beacon. It will light up at night when the plant is operating. Here's another component and just a plug. Something I'm interested in seeing once the plant is operational is that our architect and others installed a kind of a lighting feature within Georgetown. So as the treatment plant goes through the various phases of bringing different treatment processes online, different lights will light up and will be able to be viewed by the public, so you'll know what's going on and that the treatment station is working. It'd be pretty cool. So now it's kind of transitioned into augmented reality and how that's being used. And so during construction, there's been a few instances where the contractor in building the different spaces and equipment galleries and pumping rooms, was looking for some assistance in trying to, interpret the plans and the 3D model that they were working off, and wanted to go into the spaces and try to visualize what's this going to look like once we have everything put together. And so our team was able to develop some additional or QR codes. So feel free with your phone, you can scan this to see the model that's displayed on the phone here, to really see how things were going to come together. And so piping and penetrations, and I believe it was well received by the contractor and CM team. Tina or Bobby, do you want to talk about this?
Sure, I'll talk about this a little bit. So I was able to use these codes just to kind of see how the spaces were going to come together. And we provided these QR codes to a couple of the CM staff and a couple of the contractors, and they very much appreciated seeing how these facilities were going to come together. This was especially helpful at the pump station, because that pump station, just to get up out of the ground, took about 1.5 years. And so it's hard to be able to visualize what that thing is going to look like, or the stuff that you're casting in concrete today won't be installed for another 1.5 to 2 years. So it was really helpful just to give people an idea of what that finished product was going to be while they're standing on site pointing a phone at it. So I think it was helpful from that perspective.
Thank you, Tina. So that kind of finishes part 2. Are there any questions related to, I know it was a quick overview, any questions related to VR or AR and its implementation and design?
Brian, can you talk a little bit about the cost of doing this?
Yeah. So, as I mentioned, so that the first model, if you're just wanting to take your CAD model and, combine all of the components from various disciplines and get it into a space where you can put on a headset and walk around, not much cost at all. It takes someone about 30 minutes of time, provided that all the models are stored on ProjectWise or SharePoint in a location where you can get them all put together. So sometimes, file management and getting the completed model put together will take some time, but once that's done, it can be done in about 30 minutes to put on headset. So not much there, but if you do want that polished model like you saw on your phone screens or on the demo that I showed, that does take about a week worth of work. It's not highly technical work, so not that expensive, but it does take some time. So maybe a couple $1,000 to do that for a large facility. See, Emily, I see your question. So who are the software providers? How did you choose providers, differences in product software? So there's a lot, and there's more and more every day. So Jacobs has some affiliations with some providers. The model that we looked at today used an overlaying program called Enscape, which is kind of tailored to the type of work that we do, as well as doing architectural visualizations for the building industry. The one I'm most excited about, actually, and it's free, is coming from Epic Games, called Twinmotion. And personal licenses to learn the software and how to use it is free. And then their commercial licenses are pretty inexpensive. Others that are out there, like I mentioned, you can come straight out of CAD and go into a product. There's another product called Lumion, which can be used to develop these. And I'm sure there's a whole host of others. A lot of the development, though, is occurring in the UK, of all places. So most everything that we get, the default units, is meters. And sometimes there's not a way to change to imperial units. see, is there a thought of including VR things into art installations? Yeah, so Jacobs has actually done that for other projects. There's a project that we are working on in Atlanta where we've installed, there's an app for the project. It's a park and restoration project. And they've developed QR codes that actually the shapes of different frogs. And you can walk through that park and use your phone with that app installed and can see a lot of the engineering behind the restoration efforts. And so I think that we'll see more and more of the integration in our built spaces and environment as we have access to this evolving technology. See, also, could VR, AR be a tool in the future for drafting itself? Yes. So that product Twin Motion that I just talked about, I haven't fully developed it, but I know that there's now a mode where you can put a headset on and use your tools and wands to actually start creating and making the space that you're in. It's almost like you're sculpting, a much more defined Minecraft world for your project. Any other questions on this before we transition into the stormwater features? All right. There will be a time for questions too at the end. So innovative stormwater design approaches that were used for Georgetown. Part of our community engagement with the stakeholders in the Georgetown area was they really wanted a project that would enhance air and water quality, and they wanted to make the natural process visible. They really wanted to be able to see what was going to be going on. They wanted a view or a lens into the treatment station. A lot of the design reflects that. And so the pictures on the screen here are some of the representative photos that were selected for the look and feel of what they wanted for the completed project. And then our design team tried to implement those. So, and I'm sure by 2022, we'll see these at the site. So again, they wanted to enhance air and water quality while making the process visible. They wanted an understanding of public wastewater infrastructure. They wanted a project that was environmentally and socially sustainable. And they wanted a good connection to the Duwamish River and how the work at the plant was improving water quality at the river. So some of the key components in the design was the use of some permeable reinforced pavement, interior and exterior cisterns to do rainwater harvesting, a large vegetated or green roof structure. So we have two locations. I'll show both of them on the next two slides, but right across from the treatment station, we have two water vaults that are cast into the UV structure. And so as we were going through design, we noticed that there was going to be these large void spaces that we didn't have a planned use for. And so the design team figured out a way to collect roof runoff from the roof and store the water. And so those spaces combined with an exterior cistern will provide 50,000 gallons, a little over 50,000 gallons of stormwater retention and rainwater that will then be used for irrigation on the site. And so with this water, there will be very minimal need for irrigation from a potable water supply. So looking at the bottom diagram here, you can see water hitting the roof. It's collected and conveyed to the 2 cisterns here. Once those are full, it'll start filling up the external cistern, which will then be controlled, connected to an irrigation controller, which will allow water to go out to our treatment wetlands and bioretention areas. On the south side of the plant, so just behind the screenings facility, we have a series of 4 cisterns that will be collecting around 35,000 gallons of water from the roof of the screenings facility. And we are over detaining, so we're able to collect more water than we need to. Which provides a further benefit to other sites within the Georgetown area that may not capture as much stormwater as they should. Again, the rainwater here, or the collected rainwater, will be used to provide irrigation, as well as another one of the components from the public was to use the station as a public feature to provide exposure to elementary and middle school kids related to the design. And so this part of the system can be used for tours and showcase how we're collecting rainwater. Here's that reinforced pavement, and so we're putting this at various spaces along the station areas where we don't need frequent access, but do need some vehicular traffic, to particularly cranes to lift heavy equipment in and out of spaces for O&M needs. The design approach here was to, I think, use ground cover in these voids instead of grass, so there's not a lot of maintenance needed for those. And then we're using species that won't be severely impacted by that vehicular or foot traffic. And then they're all drought tolerant, so not a lot of maintenance needed. Then the vegetated roof is a pre-grown mat. It's around 6,000 square feet in size, so it's pretty large. And then we've installed kind of raised platforms, or there will be raised platforms above it for viewing. And then we have some pop-up irrigation spray. So this stormwater component, along with a lot of the other features that we didn't cover in the presentation, led to Georgetown being the first recipient of a platinum reward from the Institute for Sustainable Infrastructure, so the Envision rating system. So we're proud that we got that platinum rating. And that kind of summarizes the end of the presentation. So thank you for being a great audience. I'd like to open the floor up for any additional questions or any ads from our team members that are on the phone.
Brian, this is Jesse. I might toss out one comment if no one else has questions.
Go for it.
Stormwater design. The stormwater design has a bunch of pretty cool green elements in terms, including the cisterns and the bioretention and the green roof and everything. And the other alternative would have probably been to do something like a detention vault below the concrete or something, or I guess it's asphalt. And so early on we did a cost estimate to compare that to what looks to be a pretty expensive green system. And frankly, because the vault would have been pretty shallow and would have required pumps, we actually calculated that this green stormwater option was a potential cost saver even with a vegetated roof. So I just thought I'd toss that out there, that that I think that even I had kind of made this assumption that, oh, like, you know, green and sustainable has to cost more. And especially on this site where it actually would have been a huge pain to try to add more stuff below ground because there's so many other pipes already, you know, that I think that we not only took good advantage of the space available, but I think we even saved some cash, at least on capital cost.
Cool. Brian Dunn, did you want to highlight something?
No, sorry, Brian. I hit the wrong button. You can ignore that request. Thanks, though.
You like took control of my presentation. I gave you access too. Cool.
I'll add a couple of things about this. The question from Stephen Burgess.
Oh.
Okay. I'll address the last one first. So let's see, have you been able to include safe fail design and how do you check for that? So we did go through an extensive reliability center design effort with the county, and that started like before, right when we were at 10% design, and we checked in along every design process. And we basically went through, you know, the county's work order history, their previous facilities. We toured facilities, you know, ballasted sedimentation facilities in different parts of the Northwest. And we heard from operators about what are the typical failure scenarios. And then we discussed with the county operators, what are the best ways to mitigate those or eliminate the failure point. So we went through a pretty good effort to make sure that that we dealt with reliability issues and make sure that we kind of picked our own failure mode. So we did do an effort for that one. And then as far as the first question, let's see, looking for specific locations for corrosion prevention. So throughout the design process, we had lots of workshops with the county on certain details, and it could, I think we had 2 on corrosion. Some of them may have been on samplers. What's the best way to sample? What are your typical failure modes? How do we want to avoid those? And we did this either with VR or we did it with model screenshots inside a PowerPoint. So I think with VR, we're seeing the ability of tools. We're seeing more tools become available to have those discussions. But yes, we did, and it was on many things in addition to corrosion.
Yeah, and I'll note one of the key takeaways. So we did a VR model with a lot of the operation and maintenance staff. That once the project will be complete, it'll be theirs to take care of. And one of the components, when they went into that screening room and looked, so there's a motor on top of the screens, and those screens, you know, are pretty high up above the finished floor, and you really have to twist your neck and look up to see the screen. And so we were able to provide a little bit more space through the design process, so that wasn't such of a challenge for O&M to do their inspections on the motors on the screens. So very much other components, you know, you can walk around and look at valve placement. So there's several times with other designs where we've implemented this as a tool. You know, valves got located in areas that were hard to reach, and walking through, it was easy to identify someone can't reach that, or a person of average height can't reach that. So it's been really helpful in streamlining some of those components where, you know, just looking at a 3D model on a screen and not at a representative scale, this really helps solve a lot of those problems and challenges. So it's exciting new technology to interweave with the design process. Any other questions?
Any more questions for Brian? All right, if I'm not hearing anything, I'd like to thank you, Brian. was a really interesting presentation. Thanks for the demo and for the links. I hope everyone enjoyed it. Again, thank you for your time, and thanks everyone for all your questions. Would love to see you all next month. We're going to have a really fun presentation to talk about river dam removal by someone from the Tulalip tribe. So make sure you call in. I've posted the link to our website and our YouTube channel. Also miss this presentation, you'll find the recording on our YouTube channel. So with that, thanks Brian again, and thanks everyone, and we'll see you all next month.
Thank you all.